This is my video on magnetism. Question 1. Does a compass always point to the geographic north pole of the Earth? Why or why not? What does it point to and why? Compasses point towards the magnetic, not the geographic poles of the Earth. Because of this, where your compass is pointing and where the actual north pole is will vary, since the magnetic north pole isn't the same thing as the geographic north pole. Furthermore, magnetic poles are always shifting slightly, so even from year to year, your compass will point in a slightly different direction. Here's a diagram showing that the magnetic north pole is not the same thing as the geographic north pole. Question 2. What is the shape of the magnetic field around a current-carrying conductor, and how do I determine the direction of the field? The shape of the magnetic field around a current-carrying conductor is circular and perpendicular to the wire in which the current is flowing through. To determine the direction of the field, use the first right-hand rule. Since you know the direction of the current, you can, with your thumb pointing in the direction of the current, wrap your fingers around the wire, and the direction of your fingers is the direction of the magnetic field. Here's a diagram showing a wire and the magnetic field around it. Question 3. What is a solenoid, and what is the shape and direction of its magnetic field? A solenoid is a coil of current-carrying wire. The magnetic field around a solenoid is elliptical and runs from the north end to the southern end of the solenoid. To find the direction of the magnetic field inside the coil of wire of a solenoid or electromagnet, wrap your hand around the coil so that your fingers are in the same direction as the current flowing through the wire in the coil. Laying your thumb alongside the coil will indicate the direction of the magnetic field inside the coil. Here is a diagram showing a solenoid and the magnetic field around it. So, question 4. What is the connection between an electric motor and the third right-hand rule? In other words, explain how and why an electric motor functions. So, if a wire is moved through a magnetic field perpendicular to the field, a current will be induced in the wire as it cuts across the flux lines. Also, if a current-carrying wire is placed in a magnetic field, a force will act on the wire, causing it to move perpendicularly through the field. These are the principles of an electric motor works. Place your hand, so this is just how an electric motor works. It's saying wires moving across magnetic field creates electricity. So, and this is talking about the direction of the electricity, and so for this you use the third right-hand rule, which is describing how the flow of electricity works in an electric motor, in pretty much anything. So, you place your hand so that the extended thumb indicates the direction of the current in the wire. Your extended fingers indicate the direction of the magnetic field that is going to feel the force, and the force that pushes the wire is directed straight out of your palm. So this is my diagram, so showing that a wire moving perpendicular to the electric field, this is what's inducing electricity, and this is what's going on inside of an electric motor. So, question 5. What are the shapes of the magnetic fields? First, around a single bar magnet. Second, between two bar magnets with opposite poles. Third, between two bar magnets with like poles. And fourth, around a horseshoe magnet. So, first off, around a single bar magnet is just elliptical. Between two bar magnets of opposite poles, curved north towards south. And then the region between two bar magnets with like poles is curved up and down, because they're repelling each other, because likes repel and opposites attract. And finally, a horseshoe magnet, the field is curved from the north end to the south end, and there are a couple just going out from the north end and a couple coming in. And here is my diagram showing just the bar magnet by itself, the elliptical field between opposite poles, north to south, between like poles, up and down, just repelling, and then the horseshoe magnet with north, south, and then some going out and some going in. So, question 6. What is electromagnetic induction, and what is its connection to an electrical generator? So, electromagnetic induction means the production of electricity in a wire that is moved across a magnetic field. This is related to an electrical generator because this is how the generator creates electricity. So, essentially, it's just that what a generator is doing is moving the magnets across magnetic fields, and this is creating the electromagnetic induction, and that's how the generator makes electricity. So here is another one of my fantastic diagrams showing your wire going across magnetic field, and that this is what's happening in a generator. That's how it is related. And question 7, what path will an electron follow if it enters a uniform magnetic field perpendicular to the field lines, and why? So an electron, when it enters a field, will start in a circular or elliptical path following the direction of the magnetic field. So this is because in a magnetic field is moving charges. Charges are moving electrons, and so if you add another electron, it's just going to follow where the other electrons are going. So, and finally, here we have final diagram, and you have your wire, then you have the magnetic field around it, and when you add the electron, it just follows it. That's all for now. Thank you very much. Goodbye.